Okay, so I just wanted to make a little video for this problem and just help talk you through it. The idea is that you're trying to find the distance across this river here, and you've taken some measurements, and you're using similar triangles to find the unknown measurement x, which is across the river. So notice all the measurements are on the same side of the river, which is nice. You don't have to actually cross it first. Okay, now I want to point out the similar triangles. This is triangle ABC. It says triangle ABC. ABC is similar to triangle DEC. And each angle is marked that goes together. This A has one mark on it, so it goes with D. So these angles go with each other. So the fact that these angles go with each other means that the 50 goes with the X. And the B has two marks, and so does the E. So that means that the 65 and the 80 go together. So when you're writing the proportion, it's set up this way: the X in the 65 and the 50 and the 80. And all this proportion does is it compares the smaller side to the bigger side on the right triangle, or the smaller leg to the bigger leg. So the X is the smaller leg, the 65 is the bigger leg, and the 50 is the smaller leg, the 80 is the bigger leg. So you're just comparing those ratios, and that's why it's set up X to 65 is 50 to 80. So there's your proportion to solve for the unknown measure here, this leg of the triangle. And you can simplify first by reducing out the zeros. 50 divided by 80 is just 5/8, reduced by 10. Then you find the cross products, which means you do 8 times x and then 65 times 5. And that's what this step is: find the cross products. So then simplify by multiplying 65 times 5, which is 325, and then divide both sides by 8. And when you simplify, you get this decimal, and you round it to the nearest tenth of a foot, 40.6 feet. Okay, so that means that it's 40.6 feet across this river. So the important thing here is when you're setting up the problem, you have to figure out which sides go with what, and when you identify those, then you can go ahead and set up your proportion. And on my situation here, we just did the smaller leg to the larger leg as the two ratios. And since the triangles are similar, those ratios are the same, which is why you can make a proportion here. Okay, so I hope that cleared up some of the mystery on this complicated similar triangles problem. And if you still have confusion, feel free to send your teacher a message.